Alright guys, so we are moving into Unit 3 and we're going to do a quick introduction on minerals. Our unit's going to be minerals and rocks and minerals. So we're going to start off with mineralogy, the study of minerals. And we're going to take a closer look at what the Earth's crust is really composed of. So to do that, we need to kind of learn about minerals, right? So here's what a mineral is. It is naturally forming, inorganic substance with a crystalline structure. So naturally formed means it has to have occurred in nature. It can't be like a piece of glass that we make. That can't count. If it's glass that's formed in nature, then okay, maybe it could constitute as a mineral. Inorganic means it has to come from something that was never alive. That rules out things like coal. Coal is actually organic. It came from plant matter 300, 350 million years ago. It has to have a crystalline structure, which essentially means it needs to be a true solid. A true solid is when you have this matrix of connections between the molecules, which we refer to as crystalline. So going back to that naturally formed thing with the glass actually wouldn't work because it is not a crystalline solid. It's an amorphic solid, meaning, sure, it's solid, but it doesn't have crystalline structure. All right, of all of the minerals in the Earth's mantle, there are a total of 3,000 chemically uniquely different types. And of those 3,000, there's really only about 20 that are common. We refer to these as the rock-forming minerals. That's because when we study rocks, we're going to learn minerals all combined together is what makes a rock. So slate being a rock is actually composed of several different types of minerals. And of those 20 really common rock-forming minerals, there's really only about 10 that are really so common that if you were to take them all together in the Earth's crust, they would make up about 90% of the Earth's total crust mass. All right, from here, I want to talk a little bit about how we organize minerals, and we're going to break it down into two very simple categories. All right, and these categories are going to be based upon the elements or the atoms that are inside of them. Now I want you to take a look at this really quickly, and what you're going to notice is if we look in the Earth's crust, out of all of the common elements and atoms found in the dirt and the soil of the Earth's crust, there are a few that are really quite common. The two obvious ones here, oxygen and silicon, are going to be very important, and we're going to talk about that in just a second. But also there's a bunch of smaller ones that are still far more common than the rare, and that's the aluminum, the iron, the calcium. But let's focus on this oxygen and silicon. We break up minerals into two main categories. Those that have silicon in them and those that don't. They're the silicate minerals, that means they have it, and the non-silicate minerals, they don't have it. So it's as simple as that. You take a mineral and we figure out what it's chemically made up of, all the atoms in it. If it has Si, silicon in it, it's a silicate. If it doesn't, it's a non-silicate. Now, going back to this really quick, being that silicon is so prevalent in the crust, it makes sense that most of the minerals are silicates. And in fact, 96% of the Earth's crust is made up of silicate minerals, and only 4% are the non-silicates. And these non-silicates, you're going to learn later, tend to be the ones that are worth a lot of money, the rare earth minerals, because they only make up about 4%. So here I want to focus in on with the silicate group. I want to talk about this for a little bit. They have silica, oftentimes bonded with oxygen. We're going to talk about that during class. And here's a couple examples: quartz to the right and mica to the left. We can look at some samples of that in class tomorrow as well. But I want to emphasize they have to have this right here, the silicon atoms in it to be a silicate. And that is where we're going to end today, is quick lecture. So what we're going to do tomorrow in class is pick up on this silicon and oxygen relationship that makes the silicates. And I'm going to show you how these minerals actually arrange themselves into all the different shaped silicate minerals that we see. And we'll look at some examples too. We'll see you tomorrow.